everyone. My name is Sandeep Bhatia, Assistant Professor in the Department of Electronics and Communication Engineering at Rajkumar Goyal Institute of Technology, Ghaziabad. So, in a series of lectures delivering for a subject microcontroller and embedded systems design having code KEC 061, what we have covered so far? We have completed our unit number first and second, and in the and we are going we are currently we are doing unit number third. So, in unit number third it is divided into two parts. First part is it is divided into an embedded system, and in second part it is divided into the ARM Cortex microcontroller series of microcontrollers. So, in the previous lectures we have completed 50% portion of our unit 3, that is embedded system, and in this lecture we are going to start the ARM Cortex M4 architecture. So, these are the table of contents we will cover in this lecture, that is introduction to ARM processor, what is ARM we will see here. Features of ARM processor, what are the various features of ARM processor we will see in this lecture. After that we will cover the different ARM processor families, what are the various families and what are the various architectures available in our ARM processor. After that we will see the summary of processor characteristics, difference between the different microcontroller families. After that we will see the ARM Cortex M series family. After that we will see the design and ARM based SoC. SoC means system on chip. So, let us start with the first topic. So, basically ARM is a microcontroller. We know that in microcontroller all the components are integrated on the same chip. So, ARM originally Acorn RISC machine. Initially it is named as a Acorn RISC machine. After some time later it called as advanced RISC machine. So, ARM initially it is known as a Acorn RISC machine, and after that it is known as after some time advanced RISC machine. So, basically it is based upon the RISC processor. RISC means reduced instruction set computing. So, it is based upon the RISC architecture. So, in previous lecture we have seen the RISC and CISC processor. RISC basically a reduced instruction set computing. Basically it has less number of instructions to execute the instructions, and it has a fast operating frequency as well. So, it is one of the extensive and most licensed processor. What is the meaning of the licensed processor? Basically ARM design its processor, but it do not manufacture it. After designing it give to another company, semiconductor companies, which take the design and fabricate the architecture according to the particular family of ARM processor. So, it termed as a licensed processors course in the word. So, the first ARM processor was developed in the year 1978 by Cambridge University. So, initially in the year of 1978, Cambridge University introduced first design of ARM processor, and the first ARM RISC processor was produced by the Acorn group of computers in the year 1985. So, after some time in the year of 1985, Acorn group of computers introduced the first ARM processor, that is why it is called as Acorn RISC machine. So, these processors are specifically used in portable devices like digital camera. In digital camera we can use ARM processor. In mobile phones currently you can see in smartphones we are using ARM processor. Home networking modules and wireless communication technologies, in all applications we are using ARM processor. And other embedded systems like the which have the benefits of low power consumption. If you want to have a less power consumption as compared to other microcontrollers, you can prefer ARM microcontroller as compared to other microcontrollers like PIC microcontrollers, 8051 microcontrollers we have seen in our previous lecture, reasonable performance. So, ARM architecture is basically low power architecture, and it has a reduced instruction set computing, and basically used in large number of applications where processing speed requirement is more. So, it was founded as, after some time it is called as advanced RISC machine in the year of 1990. So, what is doing here in 1978 it was introduced by the Cambridge University. After some time in the year of 1985 it is manufactured by the designed by the Acorn group of computers, that why it is called as a Icon RISC machine, and in the year 1990 again it is it termed as advanced RISC machine. So RISC is the main CPU design strategy implemented in its processors. So British company ARM Holding, fabless semiconductor. What is the meaning of fabless? Fabless means that which are designing the ARM architecture but do not manufacture it. It gives other company to manufacture that design. So it is called a fabless semiconductor companies. So British company ARM Holdings fabless semiconductor company which develops the architecture and license to the other company. So what is happening here? ARM Holding design the architecture, okay, and it gives another semiconductor companies to design their own products that implemented one of these architectures, including system on chip that incorporates memory interface, radios, etc. So designing is performed by the ARM companies, and after designing it give to the other semiconductor companies for the manufacture. So like other microprocessor companies like Intel, we can say that Intel, Freescale, Hitachi, etc. They are all producing the, they are all designing and producing the microcontrollers, but it does not manufacture processors also, but we can say that it gives license to other semiconductor cores like Atmel, Philips, Samsung, etc. So they are giving their intellectual property rights as well. IP basically are rights which is given by the any company to the another company uh, if they want to manufacture any products. They are the copyrights, okay, they are the rights given by any company to the another company for designing for manufacture that product, okay. So these are the introduction to ARM processor. So it also design cores, they are designing the cores as well and license these design cores. So basically what is happening here, ARM company designs the core, designs the architecture and give license to other design core companies to manufacture its products. So it to a number of companies like Intel, Hitachi, etc. we have seen that incorporate these cores designed into their own products. They are giving the IPs, the copyright to another companies to manufacture it. The important IPs of ARM include its low power, it has a low power, low cost, high efficient RISC processor, we have seen in our previous slide, SoC system on chip and other peripherals. So what is happening here? ARM company design the architecture, give to the another companies, they are manufacturing it, they are providing the intellectual property right to that company, and they are integrated all the things into a SoC chip, that is system on chip, okay. So it also offer other IP apart from processor such as physical IPs, interconnect IPs, graphic cores and development too. All the things they are giving the copyright to the another companies. Apart from processors and IP cores, ARM also provides comprehensive software development tools like Keel and DS5 for developing system based on ARM. So they are supporting the various types of software development tools for the production of the IC chip, okay. So in today ARM processor are found in almost all the domains like handheld devices, consumer electronics, robotics, automation. According to the applications, we are using the ARM processor family because there are various types of ARM available like ARM 7, ARM 9, ARM Cortex boards are available. They have various types of processors as well, like A means application processors, real time processor. So according to the particular application, we are picking the ARM processor from the particular set of families, okay. So processor developed from ARM IPs are used in embedded systems like smart TVs, smart watches, smartphones, tablet computers. In all these things, we are using ARM Cortex family of processors. So now what are the various features of ARM processor we are seeing here? ARM processors are based on reduced instruction set computing architecture. We have seen in our previous slide as well. The main core feature of ARM processor is that it has a RISC based processor, but based on the requirements of the embedded system, some amendments to the RISC architecture are made. So this is the ARM features. In this diagram you can see the summarization of the various features of ARM processor. Here you can see RISC processor, load and store architecture generally. Basically load and store means that for load and storing we are using the registers here. So the loading is done into the registers, and after loading the contents which have been saved into the registers are further copied into the memory, that is called a store. Okay. So all the loading and storing of the instructions has been taken place in the through the registers. It has a thumb instructions along with the ARM instructions. It has a thumb instructions. So basically ARM processor supports two types of instructions. One is the ARM instructions, that is of 32 bits, and another one is the thumb instructions, it is of 16 bit. In our further lectures we will see the various types of instructions available in ARM processor. It has a multiple stage pipelining. Basically in simple processors there are three stages of pipelining: fetching, decode and execution. In 8051, in 8085 microprocessor, you can see that it has a three stages of pipelining: fetching, decode and executing. But in case of ARM processor, it has a three stages, it has a multiple stages of pipelining: fetching, decoding, enhancing, memory to registers, all the there are various types of pipelining stages in ARM instructions. It has some other features as well. It has a good megahertz ratio. Okay. It has a wide frequency range. It frequency range vary from megahertz to the gigahertz up to gigahertz. It has a direct Java execution. For direct Java execution, we can use JEGL instruction set. We will see in later stage what is the JEGL instruction set we can use here. It has a built-in debugger that is linked to the IC, enhanced circuit emulator, which is used to support the debugging operations. It has a enhanced DSP instructions, we will stay later stage. So these are the main features of any ARM processor. So ARM processor follow, we have seen that load and store architecture, where the data processing is performed only on the contents of the registers. So all the loading and storing take place through the registers rather than directly on the memory. So the instructions for data processing on registers are different from that access to the memory. So the key feature is it is a RISC processor. It has a load and store architecture generally. It has along with the ARM instructions, it has a thumb instructions that is of 16 bit. We will see in later stages of further lectures what are the various types of instructions. It has a multiple stage pipelining. It has a wide frequency range varying from the megahertz to the gigahertz. It has a direct Java execution along with the other programming languages. We can execute Java programming through JEGL types of instructions. It has a in-circuit emulator that is used for debugging. It has a built-in debugger and enhanced DSP instructions. So these are the key features of the ARM processor. Further, we will see the some additional features of ARM processor. The instruction set of ARM, we have seen that there are two types of instruction, ARM and thumb, that supports the basic operations. Okay. And Java execution take place through JEGL instructions. So it is uniform and fixed in length. Because why it is uniform and fixed in length? We have seen that ARM instruction is basically of 32 bit and thumb is of 16 bits. So each instruction that lie in the ARM processor is of 32 bit. It has a uniform and is fixed in length, and all the instruction that lies in the thumb instruction set, it is of 16 bit. That's why it is called uniform and fixed in length. It has a 32 bit ARM processor. It has two instruction set. We can see the 32 bit ARM and 16 bit thumb instruction set. So ARM supports multiple stages of pipelining. In the previous diagram, previous slide, we have seen that it has a multiple stage of pipelining, but in other processor it is basically there are three stages: fetching, decoding and executing in simple processor. But in ARM processor, along with fetching, decoding and executing, there are multiple stages of pipelining like enhanced, memory to register, register to memory. There are advanced stages of pipelining as well. So general features of ARM is ARM processors have a good speed of execution to power consumption ratio. It has a good speed of execution. Its execution is faster as compared to another processors, because some processors are based on CISC processor, complex instruction set computing, but it is based on a RISC. So it has a low power consumption as well. They have a wide range of clock frequency ranging from, in the previous slide we have seen that it has a wide range of frequency that vary from 1 megahertz to few gigahertz up to, we can say that 2 gigahertz to 5 gigahertz, etc. Okay. They support direct execution of Java. If you want to execute the Java programming language, this programming language can be directly executed by the JGL type of instructions. We will see in later stage, JGL DBX. Okay. ARM processors have built-in hardware for debugging, that is a IC, in circuit emulator, that is used for debugging the operations. It has a one of the main feature that it has a debugging hardware which can debug the system. If any software fault, any debuggings are buggings are happening here, it can be executed by the in circuit emulator. It supports enhanced instructions for DSP operation, digital signal processing. It has a advanced enhanced instruction set along with the 32-bit ARM and 16-bit thumb instructions. Okay. So, these are the features. So, now come to the different ARM processor families. So, we will see here the outline to the different ARM processor families. So, if you see in this diagram, you can see that there are one of the famous ARM processor is ARM Cortex board. It is basically a complicated microcontrollers within the ARM family that has ARM V7 design. So, what is happening here that these are the ARM processor families. Here you can see that there are this is the Cortex A, Cortex R, Cortex M. Cortex A means the application, A means the application, R means the real time, that is the ARM processor used for real time applications without any deadline. That means the deadline. Okay. It has a M means the microcontroller. Okay. And this is secure core and this is classic. Okay. So, if you are looking into the different Cortex families, Cortex is divided into A, R, M, and in this particular architectures, there are various types of processors like Cortex A57, Cortex A53, and Cortex A5, A7, A8, A9, A15. So, from A5 to A57 there is an advancement. Okay. And in Cortex R, the Cortex family of ARM processor available as R4, R5, R7, and in Cortex M we have different Cortex M series of families, that is M0, M0 plus, M1, M3, M4. So, basically this is a new type of processor. Okay. So, we can also add Cortex M23 available nowadays, but it did not have any enhanced DSP instructions. Secure core for SC means secure core, it has a 000, 100, 300. These are available as a secure core ARM architecture. So, in classic microcontrollers, it is available as ARM 7, ARM 9, ARM 11. So, ARM Cortex has three series of family. We have seen that A, R and M. X means that the type of processor it has. Okay. So, X for example, if we are talking about the A9. Okay. So, A9 means that it is lying in the Cortex A9 processor of families in Cortex A. Okay. If we are looking into the RX, so if X means 8, then it lies into this R4, 5, 7, etc. Okay. So, there are basically three Cortex family, and in Cortex family there are three subfamilies A, R and M. Okay. We will see one by one. So, this diagram represents that the difference between the three Cortex families: Cortex A application, Cortex R real time, Cortex M that means the microcontroller. Okay. So, Cortex A has a highest performance, Cortex R is fast response time, and Cortex M is used for lowest smallest and lowest power applications. Okay, smaller applications. So, Cortex A is basically it is used to optimize for rich operating system, for computers, for smart watches, etc. We can use ARM Cortex A application. Okay. So, Cortex R is fast response, it is basically optimized for high performance and hard real time applications. So, real time means that we did not have any delay. If you want the current execution, if you want to the system which has a real time, you have to use the Cortex R series of microcontrollers. So, basically it is optimized for high performance and hard real time applications like DVDs, robots. If you want to use robot in a high embedded applications, industrial applications, so you have to use a Cortex R series of microcontrollers. So, if you want to use Cortex M, that is it is used for lowest power, for optimized discrete processing and microcontrollers like smart bulbs, smart watches, that is used. Currently, we have seen that we are using the health watches which can monitor our daily routine. Okay, or all utilizing ARM processors. Okay, so the ARM processors are divided between the classic ARM and the new Cortex processor. Classic means ARM 7, ARM 9, ARM 11, and currently we are transformed from the classic processor into the newer Cortex processor, like we are discussing here A, R and M. Okay. So, in addition to these processors, it is divided into three groups. There are three group: classic processors, we have seen that ARM 7, 9, 11, embedded processors and application processors. Classic, embedded and application. Okay. So, we have seen that ARM classic processors include ARM 7, we have seen in previous slide that ARM 9, ARM 11. Here these are the classic processors from R7 to R11. These are the classic processors which we have used in some time back, but nowadays we are using current processors like Cortex processors. Cortex is the current advancement in the ARM processors. So, ARM 7 TMDI, this is one of the prevalent ARM architecture we are using nowadays. It is still the highest shipping 32-bit processors. If you are talking about the 32-bit RISC processors, then one of the prevalent ARM ARM processor we are using is ARM 7 TMDI. So, ARM 7 based processors are still used in many small and simple 32-bit devices. So, even though ARM 7, that is one of the famous classic processors, among these three classic processors, we have in most of the applications we were utilizing ARM 7 processors. So, it can be used for small scale embedded systems. Newer embedded devices are built using the advanced ARM embedded processors or the classic M processor or classic R processor. So, what is happening here? We are transformed from the classic processors to the new processors like ARM Cortex R and M processors. So, ARM Cortex M, it has energy efficient. For energy efficient, it has a low power consumption, simple to implement. The advantage of Cortex M ARM architecture, it is simple to implement, low energy consumption, and mainly developed for advanced embedded applications, mixed signal devices, smart sensors we are using here, airbags and automatic body electronics, all are utilizing the ARM Cortex family of processors. So, here you can see that these are the embedded processors. Embedded processors is divided into R and M, and R means the real time, and in real time we have processors vary from Cortex R4 to Cortex R8, and in M series of family it is vary from the M0, M0 plus, Cortex M3 here, Cortex M4 and Cortex M7. These are the, we are talking from this one to this one. So, R Cortex R series of processor, what is the advantage of ARM Cortex R using is that it has a high reliability as compared to other processors. It has a high fault tolerance and real time responses. If you want to use the system in a real time, you have to use ARM Cortex R series of microcontrollers. So, Cortex R series of processors can be used in system where high performance is required and which can meet the deadlines. So, it has a R4, R5, R7 and R8. So, here you can see that we are transforming from the classic ARM processor to ARM Cortex processor, that is the latest advancement. Okay. And we are, if you are going from the classic to the ARM Cortex processor, the system capability and performance is increased, and if you look transform from this one to this one, you can see that we are transforming from classic processors to the latest processor, and you are going into the latest processor from the M series to the microcontroller series to the A series applications. So, what is happening here? The processing speed of execution is increased, reliability increase from this one to this one and from this one to this one, that is from classic to ARM and from M to A series. Okay, highest performance processors. So, we are using in various types of applications like smart books, automation system, automobiles, gateways, all are utilizing the different ARM processor families. So here you can see that this is the ARM family, and from this ARM family this is the architecture. So ARM 70DM based upon the ARM MV40, ARM 9 is based upon the ARM V5T, ARM 11 is based upon the ARM V6, Cortex M is based, one of the prevalent microcontroller is ARM V7M, Cortex R is based upon the ARM V7CR, Cortex A, that is of 32-bit, it has a it is based on the architecture of ARM V7A, and Cortex A 64-bit. Nowadays we are using there are ARM A 64-bit microcontrollers are available in the market, that is based on the architecture of ARM V8 here. So application processors, it has a high performance, high efficient, ultra high efficiency. So these are the categories of various Cortex A processors from the 1757, 7370. These are categorized as a high performance. A5398, this is categorized into a high efficiency. 35, 32, 75, these are categorized into ultra high efficiency. Now summary is that application, real and microcontroller. Application are used for high clock frequency, long pipeline, high performance, and it is used as a high clock frequency. It has a long to medium pipeline, it has a short pipeline, ultra to low power we can use here. It has a MMU unit, system features, system has a MMU unit, cache memory, it has a MPU cache memory. So you are targeted market applications. So application vary from smartphone, mobile computing, high efficient servers we can utilize for application processor, and real time for real time applications like microcontrollers, automotive, hard disk controller we can use real time processor, and for microcontroller applications we can use sensors, MEMS, micro integrated scale design, Internet of Things, all are utilizing microcontroller processors here. So these are the ARM M series family of processors. This is the processor and ARM architecture. So basically architecture is a subset of the processor. So processor is made up of the ARM architecture. So this is the processor, this is based upon this architecture, M0, M4, M1, M3, M4. These are based upon this architecture. It has a core architecture of von Neumann type. Von Neumann means both the program and the data memory are allocated on the same memory space. It is ARM V7M and V7EM based upon the von Neumann Harvard architecture. Thumb instruction set, we have seen that there are two types of instruction, thumb and ARM. So basically these are based upon the thumb instruction set. Most of the instructions are based upon that, and in case of M3, M4, entire instructions are based upon the thumb instructions. So in thumb 2, another type of instruction, it has a subset of that, and entire instructions of M3, M4 are based upon the thumb 2 instructions. Hardware multiply means basically a multiplied unit which is available in the architecture of ARM. So it has a 1 or 32 cycle, and if you seen here that M3, M4, all the instructions take place in one cycle only. Hardware and divide instructions are available here only in M3, M4. It has a hardware and divide multiply. Saturated math, saturated means that in a calculator there is a limiting saturated value. If you are doing any function, it has maximum value. So saturated means maximum value in any type of processor. So it didn't have, and M3, M4 have a saturated math value. DSP extension only available in the M4, and there is no floating point, that is 7.9 float. These are the floating values. It is only available in the M4, but this is optional. So in the last slide we can see that how we can design ARM based SoC. So basically ARM processor design the things, it is given to the another companies which is integrating all the IP libraries into the system on chip. So this is the IP libraries. So these are the IP libraries available to the ARM holding companies, okay, like A9, 7, AXI, GPIO, various types of IP libraries are available. These are further integrated by the companies in a SoC and further fabricated into the ARM processor. So there are three things happening here: select the particular IP cores from this, integrate into a in a chip, and give design to semiconductor company for fabrications. So thank you everyone for your patience. I hope you have enjoyed my lecture. So in next lecture we will see the part 2 of ARM architecture. Thank you everyone.